So here we are on TryHackMe's What is Networking? This is in the Network Fundamentals course. This is the first one, actually. So yeah. Also, I already recorded this earlier, but I didn't make the video. So we've got all the answers already answered. But whatever, no big deal. Let's go. So what is networking? That's the first thing. Networks are simply things connected. For example, our friendship circle. We are all connected because of similar interests, hobbies, skills, and sorts. Okay. Pardon me. Oh, excuse me again. All right. So networks can be found in all walks of life. A city's public transportation system. Okay. Infrastructure such as the national power grid for electricity. Yeah. Meeting and greeting our neighbors. True. Our neighbors. Postal systems for sending letters and parcels. But more specifically in computing, networking is the same idea, just dispersed to technological devices. Gotcha. So take our phones, for example. The reason that we have it is to access things. True. We'll cover how these devices communicate with each other and the rules that follow. Gotcha. So in computing, a network can be formed by anywhere. What? A network can be formed by anywhere from 2 devices to billions. Oh, okay, I see. Anyway, let's say that again. So in computing, a network can be formed by anywhere from 2 devices to billions. Gotcha. These devices include everything from our laptop and phone to security cameras, traffic lights, and even farming. True. I've seen videos. Networks are integrated. Is this good enough? Hold on. Okay, let's do that. So networks are integrated into our everyday life, be it gathering data for the weather, delivering electricity to homes, or even determining who has the right of way at a road. Huh? How do you not know who's got the right of way? You better know if you're driving. Anyway, it's the person to the right. Because networks are so embedded in the modern day, networking is an essential concept to grasp in cybersecurity. Oh, I guess they're talking about stoplights. Anyway, whatever. So take the diagram below as an example. Alice, Bob, and Jim have formed their network. Alice, Bob, and Jim. What happened to Jim? We're going to come onto this a bit later on. Okay. What happened to Jim? Whatever. I hope he gets better. Hold on, man. Did I mess Jim up? That can't be. Jim can't be that bad. Jim's toast. He's a ghost. All right. Networks come in all shapes and sizes, which is something that we will also come to discuss through this module. And I guess this network is saying that they can all throw mail at each other, however, whatever, right? So answer the question below. What is the key term for devices that are connected together? Network. Okay, let's go to the next one. So what is the internet? Good question. Now that we've learned in America, we have this word is learned, L-E-A-R-N-E-D, but not in Britain. Now that we've learned what a network is and how one is defined in computing, just devices connected, true, let's explore the internet. The internet is one giant network that consists of many, many small networks within itself. I believe it. Using our example from the previous task, we're going to now imagine that Alice made some new friends named Zane and Toby. Zane and Toby. Oh, there's Jim. What's up with Jim up there? Anyway, it doesn't matter. The Zane and Toby that she wants to introduce to Bob and Jim. Okay, gotcha. The problem is that Alice is the only person who speaks the same language as Zane and Toby. All right. So Alice will have to be the messenger. Huh? I mean, I get it, but why would that be the case? Anyway, whatever. I guess it's just an example. Because Alice, can speak both languages. These two guys can communicate with these two guys through Alice. All right. Forming a new network. Gotcha. The first iteration of the internet was within the ARPANET project in the late 1960s. Okay. This project was funded by the United States Defense Department and was the first documented network in action. Yes, I believe it. However, it wasn't until 1989 when the internet as we know it was invented by Tim Berners-Lee by the creation of the World Wide Web. WWW. This guy's from merry old England. I looked him up last time. It wasn't until, and he's like a knight too. It wasn't until this point that the internet started to be used as a repository for storing and sharing information, just like it is today. Turns out. All right, so let's relate Alice's network of friends to computing devices. Gotcha. The internet looks like a much larger version of this sort here of diagram, right? So we've got network 1, we've got network 3, and we got network 2. And this is Jim. This is I guess this is Jim and the other guy, Bob. This is Zane and Toby, and if there were 2 other guys, they would be over here, and here's Alice in the middle connecting them all. I'm pretty sure that's what they're trying to say. So as previously stated, the internet is made up of many small networks all joined together. These small networks are called private networks. Okay. Where networks connecting these small networks are called public networks. Right? So we got public networks, and then the whole thing is these are private networks, and then the whole thing is a public network, I guess. Or the internet. Yeah. Okay, so the whole thing is the public network. So to recap, a network can be one of 2 types, private or public. Devices will use a set of labels to identify themselves on a network, which we're going to come onto in the task below. Okay. Who invented the World Wide Web? It was Tim Berners-Lee. Everybody, correct answer? Yes. Let's go to the next one. All right. So now we're identifying devices on a network. So to communicate and maintain order, devices must be both identifying and identifiable on a network. What use is it if we don't know to whom we're talking at the end of the day? True. Devices on a network are very similar to humans in the fact that we have 2 ways of being identified, by our names and by our fingerprints. True. I mean, there's more than that, but we have those are 2 of them. Now we can change our name through a deed poll, whatever that is, but we can't, however, change our fingerprints. I guess deed poll is the same as like going to the courthouse, I guess. I don't know. Every human has an individual set of fingerprints, which means that even if they change their name, there is still an identity behind it. True. Devices have the same thing, 2 means of identification, with 1 being permanent. These are an IP address and a media access control address. Think of this one as being similar to a serial number. Okay, but which one's the I guess this one's the fingerprints, the permanent one. But whatever, let's keep going. So we've got IP addresses right here. Briefly, an IP address or Internet Protocol address can be used as a way of identifying a host on a network for a period of time. Okay, where the IP address can then be associated with another device without the IP address changing. First, let's split up precisely what an IP address is in the diagram below. Pardon me. We've got 4 octets, 1, 2, 3, and 4. And they can go from numbers 0 to 255 for all 4 of them. All right. How many is that? We'd have to do some multiplication. I don't feel like it. 256 to the power of 4, I guess. I don't know. All right. An IP address is a set of numbers that are divided into 4 octets. Yes. The value of each octet will summarize to be the IP address of the device on the network, turns out. This number is calculated through a technique known as IP addressing and subnetting. Okay, but that's for another day. Thank you. What's important to understand here is that IP addresses can change from device to device, but cannot be active simultaneously more than once within the same network. Okay, so they can change from device to device, but you can't have them more than once on the same network. To recap, all right. IP addresses follow a set of standards known as protocols. These protocols are the backbone of networking and force many devices to communicate in the same language, which is something that we're going to come onto another time, turns out. However, we should recall that devices can be on both a private and public network. True. That's what we saw up here, right? I don't want to get into that though. Depending on where they are will determine what type of IP address they have, a public or a private IP address, depending on where they are. What does that mean? Oh, either a private or a public. I get you. So a public address is used to identify the device on the internet, whereas a private address is used to identify a device amongst other devices. Makes sense. Take the table and screenshot below as an example. We've got this right here. Here we have two devices on a private network. Okay, we've got this device here. This is the private address. Okay. We got this one right here. It's also a private address, but it's also got a public address right here. These two are the same while these two are different. All right. So I guess it's because this and this, they're like on the same router or something. Probably, maybe. I don't know. And so we see right here, when we have this thing right here, we see the IP address here is this one. So this one's going to be the private one. And same here. Then we've also got the MAC address as well. Okay, cool. Now let's go and see what the next thing says. So these two devices will be able to use their private IP addresses to communicate with each other. True. However, any data sent to the internet from either of these devices will be identified by the same public IP address. Interesting. Public IP addresses are given by our internet service provider, or ISP, for a monthly fee, which is our bill. Yes. So my public IPv4 is this right here. And so, yeah, that's this one right here. The public ones. All right. This is making me think that there's really actually no way for law enforcement to tell who is on a device at any given time, because this is the only IP address. But I guess these IP addresses are there too. I don't know if they log those though. We'll find that stuff out later. All right. As more and more devices become connected, it is becoming increasingly harder to get a public address that isn't already in use. True. For example, Cisco, an industry giant in the world of networking, estimates that there would be approximately 50 billion devices connected on the internet by the end of 2021, which was 4 years ago. Okay, and I guess that's the source. Enter IP address versions, right? So far, we have only discussed one version of the Internet Protocol addressing scheme known as IPv4, Internet Protocol version 4, I believe that's what that probably means, which uses a numbering system of 2 to the 32nd power IP addresses, which is 4.29 billion. That's way less than 50 billion, right? So we can see why there's such a shortage. True. So we got IP version 6 right here, which is the new iteration of the Internet Protocol addressing scheme to help tackle this issue. Although it is seemingly more daunting, it boasts a few benefits, okay? It supports up to 2 to the 128 of IP addresses, so 340 trillion plus. Okay, makes sense. Resolving the issues faced with IP version 4. It's more efficient due to new methodologies. Okay. The screenshot below compares both an IP version 6 and IP version 4 address. So yeah, we can see this one, instead of going up to 255, it goes up to, I don't know, I don't, is it ZZZZ? I mean, is that how far it goes up, or does it go up to FF? Is this hexadecimal right here? I bet it is, because there's an F and I don't see any A, B, C, D, E, F, G. I don't see any G's, so I bet it's hexadecimal. All right. And if you don't know what hexadecimal means, it just means it goes from 0 to 9, and then it starts at A and goes to F. So A through F are also digits, just to let you know. So MAC addresses, here we go. Devices on a network will all have a physical network interface, pardon me, which is a microchip board found on the device's motherboard. All devices on the network, let me read that again. The devices on a network will all have a physical network interface, okay, which is a microchip board found on the on the device's motherboard. Okay. Yeah, I mean, I guess that's like a serial number like they set up there. This network interface is assigned a unique address at the factory it was built at, called a MAC, a media access control address. Aha! So they will probably know our device, which device was saying the mean tweets. The MAC address is a 12-character hexadecimal number. Base 16 numbering system used in computing to represent numbers, true, just like we just said. Split into twos and separated by a colon. Yeah, so this is by twos, but this one's hexadecimal by 4. So imagine. I would say 16 times 16 times 6. So this is 16 times 16 to the 4. 1, 2, 3, 4, 5, 6, 7, 8. 16 to the 4 to the 8. So 16 to the 4 to the 8. Come on, man. All right, let's get that out. 16 to the 4. All right, that to the 8. Come on, where is it at? To the 8. Ooh. Yeah, 34 trillion or 340 trillion. That was the number they threw at us. All right, where would we? Okay, here we go. The MAC address is okay, we did that. The colons are considered separators. Right here, 1, 2, 3, 4, 5, right there. For example, this is an example. Okay. The first 6 characters represent the company that made the network interface, and the last 6 is a unique serial number. Okay, so this is the company, the vendor who built the network interface. In this instance, Intel. So that's what Intel's number is, and then the unique address of the network interface. So let's see what 16 to the 3 is. 16 to the 3. That's not a lot. That can't be possible. Oh no, 16 to the 2 to the 3. 16 to the 2. 256 to the 3. 256 to the 3. Oh, 1, 2, 3, 1, 2, 3, 1, 2. So 16 million and change, almost 17 million. Not really almost, but you get it. All right. And so there we go right there. However, an interesting thing with MAC addresses is that they can be faked or spoofed in a process known as spoofing. Okay, I'm glad we learned that. This spoofing occurs when a networked device pretends to identify as another using its MAC address. So we can just look up what spoofing is on AI, on Grok or Gemini, whatever. Anyway, let's go. When this occurs, it can often break poorly implemented security designs that assume that that devices, talking on a network are trustworthy. Okay. So take the following scenario. So a firewall is configured to allow any communication going to and from the MAC address of the administrator. Okay. If a device were to pretend or spoof this MAC address, The firewall will now think that it is receiving communications from the administrator when it's not. True, I believe it. I bet that's a little hack we just learned about. Places such as cafes, coffee shops, and hotels alike often use MAC address control when using their guest or public Wi-Fi. Okay. This configuration could offer better service, i.e. a faster connection for a price if we're willing to pay the fee per device. Okay. The interactive lab attached to this task has been made to replicate this scenario. So here's the practical. The interactive labs simulate a hotel Wi-Fi network where we have to pay for service. We're going to note that the router is not allowing Bob's. Hold on, let's open this thing up first. There's got to be a thing up here, right? All right, let's view site. Okay, there it is. All right, where are we at? We'll note that the router is not allowing Bob's packets, the blue ones. There are no blue ones, but to the TryHackMe website and is placing them in the bin. But Alice's packets, the green ones, are going through fine because she has paid for Wi-Fi. We're going to try changing Bob's MAC address to the same as Alice's to see what happens. We'll deploy the interactive tab to proceed to answer the following questions below. Don't look at this right now. Let's do this. All right. So basically it just said we're going to take what Alice's little MAC address is and we're going to give it to Bob. So let's go say Control C on this one, Control A on this one, Control V on this one, and do request site. And look at that. Bob's going through too. We're a bunch of hackers. Are we hackers yet? All right. So we type this in right at the bottom one when it asks. But let's go through the questions, right? So what's the term IP stand for? Internet protocol, of course. What's each section of an IP address called? If we go back up there, it'll say octet, but I already wrote it down, so there it is. How many sections and digits does an IPv4 address have? 4. Yes, IP version 4. Remember? We'd have to go back up there, but we could. It's right here. What does the term MAC stand for? Media access control. And now we're going to deploy this thing, and there it is right there. Copy this, paste it in there, and you're good. All right? Let's go to the next part. All right, so ping or ICMP. Let's view the site. All right, so ping is one of the most fundamental network tools available to us. Ping uses ICMP, Internet Control Message Protocol packets, to determine the performance of a connection between devices. For example, if the connection exists or is it reliable. Okay. Oh, yeah. We've all done ping before. The time taken for ICMP packets traveling between devices is measured by ping, such as in the screenshot below. Yeah, we've done this plenty on video games and whatever. This measuring is done using ICMP's echo packet and then ICMP's echo reply from the target device. Gotcha. Pings can be performed against devices on a network, such as our home network or resources like websites. This tool can be easily used and comes installed on operating systems or OSs, such as Linux and Windows. The syntax to do simple ping is ping IP address or website URL. So let's see this in action in the screenshot below, right? So we're having ping and then we have the IP address right there. So it basically is ping space either the website or the IP address, right? And that's it. And then we get these times right here. And that's pretty long, but I guess it was 6 packets transmitted. Okay. So here we're pinging a device that has the private address this. Ping informs us that we have sent 6 ICMP packets, all of which were received with an average time of 4.6 milliseconds. Yes, right here. Where's the average time though? Where does it say the average time? Oh, right here. 4.16. Ah, there it is. So that's the average. Min, average, max, max dev. Min, average, max, max dev. Max deviation. Gotcha. Right. So now we're going to do the same thing with the address quad 8 on the deployable website in this task. Pinging the correct address will reveal a flag to answer the following question below. All right. So we're just going to say ping Let's get this out of here. Let's say 8.88. What is this? Come on now. What is this? What's going on here? Oh, do we do ping here? Let's type it in here. Ping. What? Oh, let's just say 8.8.8.8. All right, so that's good enough. Send it, and it's doing its business. Taking a little bit longer than I like, but whatever. All right. So now let's answer these questions. What protocol does ping use? ICMP. Right there, ICMP. What is the syntax to ping 10, 10, 10, 10? Ping 10, 10, 10, 10. Just like what we see right here, except for this has C in it. Whatever. What's the flag when we do this? I ping the server after THM. Gotcha. All right, so let's go to 5. So we're going to continue our learning by joining the intro to LAN room. Join the intro to LAN room. What does that mean? I guess click that. Oh, there we go. Now we're on intro to LAN. And this is a premium room. And I had if you saw the first video, you know what's up. All right. So now we're on to intro to LAN. And we'll see you next time.